Okay, after this, you will notice that you will see the word standard electrode potential and another one is standard cell potential. So again, basically, these two are different. Simple to say, standard electrode potential only refer to half cell, while standard cell potential is considered two half cell or basically is referred to the galvanic cell. Okay, and then both of these will be measured at the standard condition at where it's always 25 degrees Celsius, 1 atm with the concentration of 1 molar. Okay, so the difference is the one that I highlight here, electrode and also the cell. Which one is electrode only refer to the half cell, while the standard cell potential is the combination of the two half cell. Okay, so here we continue with the standard cell potential. So normally we write E naught and then with the subscript of cell. So standard cell potential sometimes also will known as standard cell voltage, standard electromotive force. So the definition is the difference between two electrode of the two half cells. So that's why just now I mentioned when you see the word cell, that means they are combination of two half cells. So to calculate the electrode, the standard cell potential, we are going to use the formula cathode minus anode, at where I always will ask students, maybe you can try to remember, kakak tolak adik. Okay, so the kakak is the cathode lah, and then the adik is the anode. Or another formula is E naught reduction and E naught oxidation. At where for this one, you have to consider reverse the sign. While for this one, you only directly get the value from SRP. No need to do the conversion of the sign. Okay, let's look at one example. Again, here we are given two half equation, and then both half equation are in the reduction form. So based on here, we have to we know that electrode potential, which is more positive, will become the cathode. So if you want to calculate the E naught cell, so means that will be 0.34 minus negative 0.76, which is 1.1 volt, positive 1.1 volt. Okay, how about if you use the formula E naught cell equal to E naught reduction plus E naught oxidation? So as we know, if reduction means that Cu2 plus gain 2 electron and then produce Cu. So this one is maintained, so will be 0.34 volt. Okay, for the oxidation is the half cell of zinc. So in this case, the zinc need to undergo oxidation because it is anode. So the half equation will become zinc produce zinc 2 plus 2 electron. If we compare with this half equation, you will notice that the position of the zinc is different. So means that we have to reverse or we need to change the sign, become positive 0.76. So when you do like this, total up, so will still similar as 1.1 volt, positive 1.1 volt. So just easier for you, maybe you can remember the formula E naught cell equal to E naught cathode minus anode, and then you can straight away get the value from the SRP SRP table. Okay, so until this part here, you supposedly have to always know how to identify which one is the cathode and then which one is the anode based on the information given. So as we know, more positive value of the electrode potential is the one which is stronger oxidizing agent. Means that they will undergo reduction and always happen at the cathode. So what is the use of the E0 cell, standard cell potential? Basically, this value is help us to predict whether the reaction able to undergo is spontaneous or no. So if the reaction is spontaneous, the cell potential is always positive value, and where basically spontaneous means that the reaction is happen naturally. Let's proceed to tutorial question number 8. Calculate the EMF, electron, electromotive force, which also represent the E0 cell for the following cell. So this one given is the cell notation. So as we know, cell notation is as simple as ABC. So the left side of the cell notation is represent anode. So these two lines is represent the short bridge, while here the zinc is represent the cathode. And we know that the formula for to calculate the E0 cell is equal to E0 cathode minus E0 anode. So in this case, the cathode is the zinc. So refer to the SRP tables. You will notice that the cathode with the electrode potential negative 0.76 and then minus the electrode potential for aluminium is negative 1.66. So from here is negative 0.76 plus 1.66, which will equal to positive 0.90 volt. So since this is a positive cell potential, uh, so that's why this reaction is spontaneous. Where means when you connect these two aluminium at anode and then zinc at the cathode, they will produce the electricity with the voltage 0.90 volt. Tutorial question number 4. By referring to the SRP table, predict whether the reaction is spontaneously or no. So from here, you are given the overall equation. So basically, you need to identify first which is anode, which is cathode. So silver produce silver plus. So we know that silver is the anode. Okay, then the nickel will be the cathode. So the SRP value for the anode, the SRP value for the silver is positive 0.8, while nickel is negative 0.25. So for the question A, E0 cell is cathode minus anode. So the cathode is negative 0.25 minus the anode is positive 0.8. So when no need to press the calculator, basically we know that this is a negative value. So this is non-spontaneous. Non-spontaneous. However, when you do the calculation in the question, you need to show the value, yeah? Okay, then next one, we continue with the B. So in this case, calcium 2 plus. So calcium is the anode with the electrode potential negative 2.87, while D2 plus will become the cathode with the electrode potential negative 0.4. So E0 cell equal to cathode negative 0.4 minus negative 2.87. So without pressing the calculator again, we will know that it is positive value. So this one will be the spontaneous reaction. So again, you need to determine, you have to press the calculator and show the exactly value, yeah? Okay, then next one we proceed with C, Cu plus to Cu2 plus. Again, Cu plus is undergo oxidation, so this is the anode. Then please alert with the half equation. You may have two half equation. One is Cu2 plus to Cu. Okay, Cu2 plus to Cu, and then they will have another is Cu plus to Cu. Cu2 plus to Cu plus. Make sure you choose this one. So the value is positive 0.15, while for the Fe3 plus to Fe2 plus it's positive 0.77. So for question C, the E0 cell equal to positive 0.77 minus positive 0.15. So basically we know that this one is 0.62 volt, which is positive value, so it's spontaneous reaction. Okay, last part of the question, number 4D, Br negative to Br2. So from negative 1 up to 0, the oxidation number. So again, this is the anode. So when we refer to the SRP value, this one is positive 1.07, while the cathode SN2 plus is negative 0.14. So for donkey E0 cell, the cathode is the SN2 plus, so will be negative 0.14 minus positive 1.07. So basically we know this one you will get the negative value, which is non-spontaneous reaction. Okay, now we still in the tutorial question number 5. By referring to the following data, so when we look at here, basically this is part of the SRP tables. They already extract for us which one they need to refer. So which of the following species, we have 4 species here, can oxidize the Fe to Fe3 plus. So from here we know that Fe to Fe3 plus is oxidation. Then oxidation is always happen at the anode, and the E0 electrode basically will be more negative value. So now here is very simple. If Fe undergo oxidation, means that I2 need to undergo reduction. So if it need to undergo reduction, happen at the cathode, and then the E0 need to be more positive. So in simple words to say, as long as the SRP value for these 4 species is more positive than iron, then the reaction is happen. So in this case, iodine, yes, it is because the electrode potential for the Fe3 plus to Fe is negative 0.04. So for this case now here, positive 0.53 is more positive. So iodine can be oxidized Fe. Silver also can be oxidized. Ag plus also can oxidize the Fe to Fe3 plus because the value is positive. While the aluminium is negative 1.66, which is more negative, so cannot. And then Pb2 plus also negative 0.13 volt, which is also more negative than negative 0.04. So Pb2 plus also cannot oxidize Fe to Fe3 plus. So simple word to say, in this case, only 2 species can oxidize Fe, which is the iodine and also the silver plus. Now let's look back at the tutorial question number 1, which we didn't discuss in the earlier of the video. So I think by combining the 2 video previously and this video, so we can do a very simple and quick summary by using the question number 1. Standard electrode potential for the silver and the lead is positive 0.799 volt and negative 0.126 volt respectively. In Bahasa is masing-masing. So determine the anode and also cathode. As we know, cathode always with the more positive electrode potential. So the cathode is the silver, is correct. If you write silver plus silver, then this is wrong. Basically, this notation okay, is considered as a half cell. Okay, so the anode automatically will be the lead lah. Okay, and then draw and label the cell diagram. So in this question, I will not repeat this part because we already discussed this one. We draw it quite a lot in question 2. Okay, so basically the setup is almost the same. Only the label for the cathode is the lead, and then the solution is Pb2 plus, and for the anode, for the anode is Pb and Pb2 plus, while the cathode is silver and the solution containing silver plus. So write the overall cell reaction. So that means it seems like the chemical equation. So as now we know that cathode is silver, and where silver will undergo reduction, so which is Ag plus equals gain electron, and then will produce silver solid, while for the anode will be the lead which undergo oxidation, lead solid, and then produce Pb2 plus equals with 2 more of electron. Because of we want to write the overall equation, so the number of more of electron have to be similar, so the equation of the half equation at the cathode need to be times 2, and then the electron can be cancel each other. So here end up we have lead with the 2 more of silver ion, and then going to produce 1 more of Pb2 plus and 2 more of silver. So this is answer for the C. So next one, they ask us to calculate the standard cell potential, which we need to find the difference or combine the two half cell, which we use the formula cathode minus anode. So in this case, the cathode is more positive one, which is plus 0.799 volt, minus anode is negative 0.126. When we press the calculator, you will get the answer 0.799 plus 0.126, which is equal to positive 0.925 volt, and then this reaction is spontaneous. Always remember to highlight the sign, either is positive or negative, and the reaction is spontaneous or non-spontaneous. Next part of the question, they ask us to identify which electrode will increase in weight. So basically means that the electron will become thicker. So we can refer to the half equation over here. So based on the half equation here, we will notice that lead electrode will dissolve because become lead 2 plus. But the silver ion will undergo reduction to form silver. So that's why which electrode is increased in weight? The answer is silver electrode, because explain the answer. The Ag plus is reduced to form silver. Okay, so that's why silver electrode will become thicker and thicker. So last one is the name the oxidizing agent. So oxidizing agent is the species which will undergo reduction. So based on here again, the one undergo reduction is Ag plus. So this is the answer for F. Okay, now let's continue with the objective question, at where the question asks us which of the following pair may react with each other. So if they can react with each other, means that reaction is happen, so the reaction is spontaneous. So if the reaction is spontaneous, means that the E naught cell will equal to is positive value. Okay, is positive value. So now we want to check with the Fe2 plus with the Br2. So Fe2 plus with the Br2, Fe2 plus is here, and then this is Br2. So for in this case, because of the means that Fe2 plus will undergo oxidation, become anode because Fe2 plus as the reactant. Okay, so this one is the anode, while Br2 will become Pr negative, so it's undergo reduction, so this one will be the cathode. So when we minus, positive E naught cell will equal to positive 1.07 minus 0.76 volt. Basically, we know that this is positive value. So first pair A is accepted. Then now we try to look at pair B. Okay, Fe3 plus is the reactant, means that they're going to undergo reduction. So in this case, Fe3 plus here is the cathode, and then Br negative is the reactant. So and then will become Br2, so it's the anode. So cathode is negative for pair B, negative 0.76, and then minus positive 1.07. So basically we know that we will get negative value. So pair B cannot be cannot be react with each other. Okay, next one is the C, Fe2 plus, okay, as the reactant, so become Fe3 plus, so Fe2 plus in this case will be the anode, while I negative also will become the reactants and then to form iodine. So in this case, both are undergo oxidation, so it is not possible. Okay, because to carry out this must be one undergo oxidation and then another one undergo reduction. Okay, last pair, iodine become I negative, so that means this one is undergo reduction, iodine as the cathode, and then Br negative become Br2, so this one is oxidation, is anode. So again, we use cathode, E naught cell equal to cathode. Cathode is positive 0.54 minus the anode is positive 1.07. So positive minus here will become negative value. So pair D also are not accepted in this question, will not react with each other. So only question 1A will react with each other. So I think we already finished the tutorial question for the topic of galvanic cell. So thank you for spending the time and hope you get some idea from this video. See you in next video, which is Nernst equation.